Talking about ratios and proportions, and we're going to use that to talk about similarity. So a ratio is a comparison of two quantities. When we use the word quantities, this just means numbers or amounts that are measured in the same units. The ratio of A to B can be written two ways. One way is like this, A with a little colon, A colon B, like that we would say that, A to B. Or we could write it as A over B as a fraction. So either way is fine. We use this more but you'll see the other ways plenty of times. So like in the problem down there, you see it. So we want to be able to do both. Okay, so writing each ratio in simplest form, all this really means is simplify the fractions. So when we look at 18 divided by 24, what do both of those numbers divide by? What's the number that goes into both of them? 6. So we divide the top by 6, we divide the bottom by 6. What's 18 divided by 6? 3. 24 divided by 6? 4. So this would be 3 over 4 when fully simplified. Okay, when I do number 2, so maybe I notice right away that 2 goes into both of these. So I divide the top by 2 and the bottom by 2, and I get 4 over 6. Is 4 over 6 fully simplified? No, what goes into 4 and 6? 2 again. Okay, so sometimes you don't simplify all the way right away, and that's fine. So I'll divide them both by 2. I get 2 divided by 3. So maybe I notice at the beginning that they both divide by 4, or maybe I don't, and that's fine. Okay, go ahead and simplify those fractions for 3, 4, and 5. Ready, set, go. Okay, so 9 over 6, what does that simplify to? 9 over 6? 3 over 2. 18 over 36? Was it? 1/2, yep. And 40 over 12? 10 over 3. Okay, so again, maybe there's some steps in between. That's fine. We want to get where it's fully simplified, where nothing divides into both the top and the bottom. Okay. Here's some examples of how we can use ratios to solve problems in geometry. So the measures of 3 angles in a triangle are in the ratio of 2 to 2 to 5. So we have 3 things in a ratio here. So it's really a ratio as a comparison of quantities, not 2 quantities, because we could have 3. And it says find the measures of the 3 angles. Okay. So here's what we want to do for a problem like this. We have our ratio there, and we have the 3 angles of a triangle. And so to get them to have that ratio, what we want to do is write 2x, 2x, and 5x.
This just means -3 for this one.
That's fine. He does math inside a lot. Because you got it. Okay, once we have this picture, what would our equation be? Jackson.
2x plus 5x equals 180.
Yeah. Okay, so we know that all three angles of a triangle add to 180. So we want to use that knowledge right here to set up our equation. Combine like terms. We get 9x equals 180. And then we divide both sides by 9. And I get x equals 20. Am I done with this problem? No. What's the problem asking for? Yes. So we're being asked to find the measures of the angles. So that means I have to take 20 and I have to substitute it back in. So what is 2 times 20? 40. And what's 5 times 20? 100. Okay, so those would be our three angles. Okay. Questions on that process? All right. Now we have the measures of two complementary angles is 4 to 5. Find the measures of the angles. What does complementary mean? Lassie? They add to 90. Okay, so this is going to be very similar to our process for the last one. Last one we were told they add to 180. So we took this ratio and turned it into a picture and an equation, and added to 180. Can anyone think of what our equation would be for this? If our ratio is 4 to 5. Lee, what do you got? 4x plus 5x equals 90. Very nice. Yes. If you wanted to draw a picture for this, you could draw a picture like this with a right angle and have it split into two angles here, 4x and 5x. Or you could go straight from the ratio here to the equation. So we have 90 on this side because they add to 90, 4x plus 5x because the ratio is 4 to 5. Here I get 9x equals 90. What does x equal? What? 10. Am I done? Substitutes, yes. Okay, so x into 5x, x into 4x. 5 times 10? 50. 4 times 10? 40. That would be our answer right there, 50 degrees and 40 degrees. You might be able to do that in your head from the beginning. If you see 4 and 5, they add to 90, you're like, oh, it's got to be 40 and 50. That's great. If you can do it in your head, that's great. Sometimes this would be hard to do in your head, right? The first one. So don't rely on being able to do it in your head. You can always try and do it in your head. But don't rely on it. Okay. Next, we have the perimeter of a rectangle is 40 feet. What does perimeter mean? What's that? Yes, the length of the sides added together. Yes, exactly. Okay, so if we add this plus this plus this plus this, it's going to equal 40. The ratio of the width to the length is 2 to 3. Find the length and the width. Okay, so what could I put as the width for my picture here, given this ratio? 2x. Nice. And what would I put as the length? 3x. Now with the rectangle, remember that it's not just one side every 3x, it's the two opposite sides. And same thing with width. Also, I just want to point out, it's totally fine. Length and width really don't matter that much, which one's which. They're really the same thing. So this picture looks a little bit strange because 3 is bigger than 2, but we would get the right answer if we drew the picture this way. So it doesn't matter that much. Okay, so perimeter is 40. What equation do we set up to solve for x? Turn to your partner. What equation could you set up to solve for x? What do you think? Okay, ideas on an equation? What do we got? Tate? Okay, 6x plus 4x equals 40. Where'd you get the 6x and 4x? Yes. So yeah, we have our 3x plus 3x and our 2x plus 2x. Yeah, so we want to add all the sides together to equal 40. So in total, we're going to get 10x. Okay, and then of course we'll divide by 10. So x equals 4. Are we done? No, we have to substitute. Okay. So our length and width are 8 and 12. It doesn't matter which one you call the length or the width. That's fine. We could just say 8 and 12. One could be length, one could be width. Okay, go on to the next page. Okay. All right, next term here, a proportion is an equation. I don't like saying that equates two ratios. That's a little repetitive, and that's not a great definition. Is an equation, we can just say of two ratios. That's not a good definition to use the term in the. So it's an equation of two ratios. So if AB if the ratio A to B is equal to C to D, then we can just write A over B equals C over D. All of this together is called a proportion. Okay, a way that we usually solve proportions is using the cross product property, which says that you can cross multiply. So that means that we would multiply A times D equals B times C. So we multiply diagonally. Sometimes people get this confused with something like 1/2 times 2/3. Could we cross multiply on that problem there? No, what's the difference between the two? Yeah, they're not equal, they're being multiplied, right? So in this proportion, we have an equal sign. In the multiplication problem, that's just a multiplication problem. When I do this, I would want to cross off the 2's and get 1/3. So we do not cross multiply for that. We're looking for an equal sign. Okay. So equal sign right there. We're going to cross multiply. We're going to do 4 times x. What is that? 4x equals 3 times 12. What is that? 36. And then we're just going to solve for x. Divide by 4. Get x equals 9. Okay. When we do this one here, what's 3 times y? 3y. So when we cross multiply here, go ahead and take an extra step and just write 15 parentheses y minus 2. So we want to make sure we use parentheses to multiply 15 by that. Once we have our parentheses, what would I want to do? Yeah, we want to distribute. So now we get 3y equals 15y minus what? 30. And now we could just solve. So I could subtract 15y from both sides. What's 3 minus 15? Negative 12. So we have negative 12y equals negative 30. Divide both sides by negative 12. And we would just want to simplify this fraction. So what's a number that goes into both 30 and 12? 2. Can we think of a bigger one? 3. Can we think of a bigger one? 6. Yeah, 6 goes into both of these. Again, it's okay if you don't notice right away. This would be 5 over 2. Remember, negative divided by a negative is a positive. Go ahead and do number 3. Ready, set, go.
Front page on all of them.
Okay. So let's move on to some geometry ones now.
Exciting.
Exciting. Okay, so we have an example that's done here for us already. So we are told here that AB to BC is 2 to 5. So one thing that's really important in math is when you see the word is, hey guys, listen please. Is means equals. Whenever you see the word is, that means equals in math. So when it says AB to BC, that's right here. We have AB to BC is, that's equals 2 to 5. So we set up a proportion based on this information. And then we go look at the picture and we see, okay, AB is right here. That's X. And BC is right here. That's 20. So we're substituting those lengths in to get X over 20 equals 2 over 5. We cross multiply and solve. So we'll do the same thing here for number 2. MN to MO, so we'll just do MN to MO is 3 to 4. That means equals 3 over 4, like that. And then we're going to substitute in the values. What does MN equal? 9. And MO? X. So we have 9 over X equals 3 over 4. Might be able to do this one in your head and see that X is 12. If so, great. If not, also fine. We just cross multiply. 3X equals 36. So X times 3, 9 times 4. Divide by both sides by 3. And we get X equals 12. Questions on that process? All right, take a second and do number 3 if you haven't already. So we got DE to EF is 1 to 2. What does that look like once we substitute the numbers in? What's that? What's DE? 4 over 2x is 1 to 2. Okay. We cross multiply. 2x times 1 is 2x. 4 times 2 is 8. What do we get for x? Okay. Questions on that? All right, let's go to the next page. Okay. Do these two, numbers 1 and 2. Where's that go? All right. Let's check these here. Braden, can you give me your equation for number 1?
Number 1?
Yes.
44 over x equals 8 over 5.
Equals 8 over 5. Do we agree? 44 over x equals 8 over 5. Okay. So we got 8x equals, what's 44 times 5?
220.
220. All right. And then 220 divided by 8?
27.
27.5. All right. Yeah, I would need a calculator for that one. Or I would need to show my way.
What did I say? I asked you to use the calculator and you said no. Yeah, because someone here at your table said.
Okay. Jackson, for number 2, what did you get?
I didn't do number 2.
You didn't do number 2. Okay. Then you can bring your computer up to me, and I'll take it.
I have to talk with the calculator.
Okay. So, Where we really use proportions is in something called similarity. So right here, this statement, this symbol right here is that. It's kind of like what goes on top of a congruence symbol. It is what goes on top of a congruence symbol. It means is similar to. We'll talk a little bit about what similarity means right now and in a little bit, and then that's kind of what our unit is about, similarity. So this is congruent. This is similar. Okay, and so we have our picture here. Guys, listen up, please. So we're saying that triangle ADE, which is this triangle right here, is similar to triangle ABC, which is this triangle right here. And so by following these letters, very similar to what happens with congruent triangles, A and A correspond. So those angles are the same. D and B correspond, so those angles are the same. And C and E correspond, so those angles are the same. And then we can see here, would you guys say that AD and AB are the same length? AD and AB, are they the same length? No, definitely not, right? There's AD, AB is clearly longer. So similar does not mean that the lengths are equal. What it does mean is that they are in a proportion. So we say the lengths are proportional. Okay, and we're going to use this ratio up here to help solve the next couple problems. So we'll do number one. We see that AD is 2 and AB is 4 and AE is 3. And we're looking for AC, so we're looking for this. So we'll make that X. So what we're going to be doing here is we're going to be setting up our ratios of the small triangle over the big triangle. You don't have to do it like that, but that's just what we'll do. And we're also using this one here at the top. So AD is 2. And what side goes with 2 on the big triangle? 4. And then from the small triangle, what side would we use? 3. And then that goes with what? X. Yeah, so we're going small triangle, big triangle, small triangle, big triangle. And we're matching the sides that go together. Yeah, we might be able to solve this one in our head just by looking at it. X is 6. Or we can cross multiply.
Yes.
Okay. So what we did was we matched up the sides in the proportion. So we'll do another one here. We'll still do small triangle over the big triangle. So we have ED is 4. AE is 5. AC is 10. And we're looking for BC. So if I start off with 5, what would I want to put that over? 10. And then, so that's small to big. What would I want to do on the other fraction there? X over 4? 4 over x. Because we want to go small to big. Here's the small triangle. Here's the big triangle. Okay, again, sometimes we'll be able to do this and solve it in our head. What does x equal? 8. Yeah, because we can see the ratio is 1/2. Or cross multiply. It's fine too. Okay. You guys try numbers 3 and 4. I actually don't think that's a typo. I think that's there on purpose to show you that it's not possible. So again, this one's not possible because 5 does go with 8s, but 4 does not go with x. 4 goes with this side right there. So we could figure out what y is, but that's not what the problem is looking for. The problem is looking for x. And we don't have enough information. We would need to know that side right there. Okay, what does our equation look like for number 3? What's our equation for number 3? 2 over 6 equals x over 8. So we get 6x equals 16. So AE is 8 over 3. All right, let's go to the next page. Okay, so we're going to talk more about congruence versus similarity. And we just talked a lot about congruent triangles. So right here, if we're told that ABC is congruent to DEF, then that means that angle A is congruent to which one? Angle A congruent to? Angle A congruent to? D. A congruent to D. Angle B congruent to? E. And C congruent to? And then we know that AB would be congruent to DE. BC congruent to DF. And CA congruent to FD. Nice. Okay. So that's congruent. And that was our last unit. Oops.
Are we done with the proof?
Maybe. Maybe not.
Thanks.
We might see a few more, but yeah, we won't see very many more. Okay, so congruent figures have exactly the same angles and sides. So all of their angles are the same, all of their sides are the same. Exactly the same angles and sides. Sometimes we can abbreviate this as saying same shape. same size. You might have heard a previous math teacher describe it like that. That's what I hear a lot. I like it. Same shape, same size. Similar figures have exactly the same angles, but not necessarily the same size. We usually say same shape, different size. We use similarity a lot when we're building stuff, like just in real life. So we can see here these two guys, these architects or whatever, they're designing. It's kind of blurry, I know, but they're designing a house. So, oops, I need to click on that. So they built a smaller version, but it has exactly the same shape because they want to know exactly how the house is going to fit together. The construction workers for our school, right? They have blueprints. They have drawings on a piece of paper. Is that piece of paper the same size as the school? No, that would be impressive. I would like to see a piece of paper like that. But no, they're drawing a smaller version on a piece of paper that is the same shape, but it's a different size. It's not going to be very helpful if they draw it, you know, the wrong shape, and then the measurements wouldn't line up, and then we wouldn't be able to build the building, right? So it's got to be exactly correct, but a smaller version. So this is what similarity is talking about. A smaller version that represents something larger, or vice versa. So two polygons are shapes. Two polygons are similar if their angles are congruent. That's what gives them the same shape. And their sides are proportional. And so proportional means they have the same ratio. It means the ratios are equal. Okay, so we looked at this a little bit on the previous page. But if ABC is similar to DEF, that does mean that A goes with D. A is congruent to D. B is congruent to E. And C is congruent to F. The angles are the same. I kind of don't like drawing those shapes on there. A little too blurry. Okay, but the sides are proportional. So I'm going to go from small to big, just like we were doing before. Which means when I do AB, what would AB go over? What would be underneath here? What matches with AB? DE. So maybe I could label those as 1 and 1. That kind of looks like no, maybe not. I got to think of a better way to label them. When I do BC, what does BC match up with? EF. And then AC matches with EF. So we're not saying they're equal, we're saying they're proportional.
Why did you say B equals B?
Oh, yeah, you're right. It should be E. Yeah, thank you. Okay. This is kind of interesting. It's sort of just a repetition. It's the converse, actually. If corresponding angles are congruent and corresponding sides are in the same ratio, then the figures are similar. Okay, so given this right here, that statement, it's called a similarity statement. I want you guys to do the same thing here that we did up there. What goes with angle X? What goes with X? S. What goes with T? What goes with T?
Y.
Y. What goes with W? Okay. We'll go small to big. You don't have to go small to big. You can go big to small. But we'll go small to big. If I go TW, what goes with TW? YD. If I do XW, ES or SD, the order is fine either way. And then TX, YS. All right. Okay. So take a look at these two trapezoids here. I'm not going to fill all of this out, but we're told right here, Jackson, I need you to turn around your seat. We're told that they're similar, which means the angles are congruent, the sides are proportional, which means they have the same ratio. That ratio that they have between them that's the same is called the scale factor. So, as we look at these two trapezoids, we know that the angles match up. We're told that already. And we know that the sides are proportional. So we don't really need to do all this. I'm going to skip over that right there. But I want you guys to notice, okay, this side is 10. What's the corresponding side on the other? 20. Okay. So our ratio is 10 to 20. Or I could see it's, 6 to 12 or 4 to 8. What does that simplify to? 1/2. So we would say that the scale factor from small to big is 1/2. A 1 to 2, or 1/2 scale factor. If I said from big to small, it would be 2 to 1. So let's do scale factor from big to small of the next one. What does that equal? Big to small. 5 to 20, that's small to big.
25.
20 to 5, okay. Does that simplify? That simplifies. Okay, now because it's a ratio, we want to write 4 to 1. because it's a ratio.
So what is all the rest?
That's to set up the, I mean, I don't know why there's 3 different ones, but it's supposed to be like 2 to 8 equals 5 to 20 equals, it's just a lot. I don't want to do that. So if I said scale factor from small to big, what would that be? Yeah. 5 over 20, which would simplify to 1 to 4. So the order matters, but it's just the ratio between them. So if I go 2 to 8, it's the same thing. 2 over 8 equals 1 over 4. 8 over 2 equals 4 over 1. Okay. So I've got these 2 triangles here that are similar. So we know that angle F is congruent to what? D. We know that R is congruent to A. Okay, so we know that R is 60. I can fill that in there. And I know that I is congruent to Y. Okay, so I know that Y is 40. What would angle F and D measure?
80.
80. Very nice. Remember, those add up to 180. Okay. What is the scale factor from small to big?
4 to 6.
4 to 6. Yes. Okay, so 8 doesn't match up to anything. 9 doesn't match up to anything, so we have to use 4 and 6 because they match up. 4 to 6, which is 2 to 3.
How do you determine if you do big to small or small to big?
It should say in the directions. It doesn't in these notes, which I didn't notice until I printed them out. But it should say. Or it'll say like from triangle FRI to triangle PAY, it should say. Okay, so if I make RI X, what does X go with? 9. And what's the scale factor again? 2 to 3. So it should be 2 to 3 for every side. It would be, yeah, it would be 6. Yeah. So we could cross multiply here. And dy I can make y. So how would what proportion would I set up to solve for y?
X over
Let's use y.
8 over y
8 over y, yep, because they match up,
equals 2.
equals 2 over 3. So we want to use that for all of them.
2y equals 24. Y equals 4.
So you have a homework on Delta Math. It's called 6.1 Intro to Similarity. It's assigned to you. You're going to finish that by next class, which is Tuesday. And that's it.